All right, guys, these are notes for section 5.2. In section 5.2, we're going to continue writing equations for proportional relationships. And you can see here that, I guess let me just get to it. The learning target is we are going to write equations for graphs. Most of this homework is about showing you a graph of two quantities that represents a proportional relationship and figuring out an equation for the graph. So let me first talk about proportional relationships. It's what we went over last section. I want to remind you of a couple things. First of all, just vocabulary. Direct variation means the same as a proportional relationship. You might say that two variables have a proportional relationship, or you might say that two variables vary directly. I guess the point I want to make is that these two things mean the same thing. Having a proportional relationship and two variables that vary directly with each other, or called direct variation, mean the same thing. When you have a proportional relationship, the equation for the relationship between two variables will always be y equals k times x. There'll be some number that you can multiply times the input, we call that k, to equal the output, or the y. And the k value is always a rate, right? Like miles per hour, inches per year. Its units will always be the y units per the x units. So if you know the units of the two variables, if you know the units of the two quantities you're measuring, then you know the rate as k. All right, I've done an example here for you. I bought a plant for my classroom when I started teaching, or perhaps my wife bought the plant. I measured its growth each year and recorded it on the graph below. So this is pretty much what this section is about. Can you take a graph and write an equation for it? We want to write an equation that models the growth. So, first of all, we know that this is direct variation. Since it goes through the origin. All right, since it goes through the origin, we know we have direct variation or a proportional relationship. And so our equation is y equals kx. All right, first we got to know it's a proportional relationship, and we know that because it goes through the origin. And so we know our equation would be y equals kx. So to write an equation, we need to find k. Right? And we know that k is equal to y over x. So we go over to our graph and we pick an ordered pair. Like I picked the ordered pair, x equals 2, y equals 6. And that means that the k value would equal 3. And once I know the k value, then I can write the equation. The equation would be y equals 3x. That would be the equation for this graph. Next up, we want to know at what rate the plant is growing. Well, K is the rate, right? We just found K, and K is the rate. In fact, K was equal to 3. So, 3 inches per year is our rate, right? And inches is the Y units, and years is the X units. So that fits our model that the K value is always the Y units per the X units. In this case, 3 inches per year is the rate. All right, so again, the focus of this section is taking a graph like this one and writing an equation for it like this one, and recognizing that the K value is the rate. All right, we also want to be able to compare rates, whether we're given a table, a graph, a story problem, description. We want to be able to compare rates to see which one is greater, which one is less. The key to this, I think, is finding the K value, since, of course, the K value is the rate, right? So I've got an example of that for you. Jack has been saving money from his pay each week in a savings account. The equation y equals 40x represents the amount in the account y. So the y value is how much is in the account after saving for x weeks. So my x value is weeks, my y value is the savings in the account. His wife Jill also has been saving money. Her savings are modeled by the graph below. You can see in the graph below that her x value is also weeks, and her y value is the amount of money she has in the account. And we have several questions we're going to answer about this situation. First off, at what rate has Jack been saving money? Well, Jack's equation is y equals 40x, so k equals 40 for Jack. Therefore, he is saving $40 per week, all right? K value is the rate. Part B says, write an equation for the line that models Jill's savings. All right, well, it goes through the origin, right? So it's a proportional relationship. Proportional relationship because it goes through the origin. So her equation, again, is going to be y equals k times x. I just need to figure out what k is. And to figure out what k is, I take any ordered pair on the graph, like say this one, and I use the x and the y value from that to calculate k. So in this case, that would be 90 over 2, or 45. So her equation would be y equals 45x. All right, y equals k times x. Part C says, at what rate has Jill been saving money? Well, we just saw that Jill's K value was 45, right? And that'd be 45 Y units per X units, or dollars per week. So $45 per week. The next question is asked, who is saving more money per week? Well, obviously, Jack was saving $40 per week, and Jill was saving $45. So obviously, Jill is saving more money per week. That was kind of silly. And last up, how much will Jill have saved in 16 weeks? All right, well, this is one of the reasons we would like to have an equation for a graph. We would go ahead and use the equation for Jill. Her equation was y equals 45x, and then sub in 16 for x weeks, and that would be y equals 45 times 16, substituting 16 in for the x number of weeks. And when you multiply that out, you get 720. So, in 16 weeks, Jill will have $720 then, right? That is a good use of the equation. It's why we write the equation, so we can calculate other amounts. And last up, all right, just in review, for proportional relationships, if I give you a graph, can you write an equation for it? So all you do is pick unordered pair on the graph use it to calculate k, because k is equal to y over x. And once you do those two things, then you can go ahead and write the equation. Well, what if you're given a situation? Can you write an equation for it? Here you can use the rate from the situation for k, or if they don't give you a rate, you could make a table. Then find k, and once you do those two things, then of course you can write the equation. All right, it's all about writing the equation on this homework and then maybe comparing the rates. Good luck.